Hi everyone. Today I'm delighted to introduce John Brewer from Amorphyx. John is the CEO of Amorphyx, and today he will tell us about their thin film transistors and how they eliminating the roadblock to the next generation of displays. So John, just the stage is yours.
Thanks. Thank you, Christoph. Welcome. My name is John Brewer. I'm the CEO of Amorphyx. Thank you for joining me for this discussion of the company's path to a new generation of high-performance, highly manufacturable flat panel and flexible displays based on Amorphyx developments in next-generation thin-film electronic devices. Next slide, please. In the early days of LCDs, thin-film transistors had a relatively pedestrian function: produce a variable voltage in response to a data signal to control the polarization of liquid crystal. Making a variable analog voltage with a very low on-off duty cycle is about the easiest thing a transistor can be asked to do. But the transition from LCD to light emitters, OLEDs and micro LEDs, stresses existing TFT technologies beyond their manufacturable limits. Light emitters, similar to incandescent light bulbs, require continuous electric current to emit light. Continuously making large time-varying currents while shrinking the TFT footprint for higher resolution is by far the most difficult thing a transistor can be asked to do. Next slide, please. While amorphous silicon supported TFT performance sufficient for the early days of LCDs and continues to be sufficient for commodity-grade image quality and power consumption, silicon is far from capable of meeting the requirements of high-performance, small area and large area OLED and micro LED displays. Speed, output current, physical size, stability, power consumption, and manufacturability are uncomplementary TFT parameters. To improve one, the others are compromised. Laser annealing amorphous silicon dramatically increases speed and output current, while dramatically compromising stability and manufacturability. In response, the display industry developed compound semiconductors, metal oxides, specifically indium gallium zinc oxide, IGZO, to improve speed and output current without compromising the other parameters. After 15 years of development, IGZO is in mass production in a subset of premium-grade smartphone, tablets, and monitors. But its improvements in speed, output current, and power consumption, incremental on silicon, are of limited value as manufacturability and physical size compromise its broader applications. Next slide, please. Today's OLED smartphone displays consume 65 to 70% of smartphone battery energy, by far the largest consumer of battery energy in the smartphone platform. LTPS's high manufacturing complexity, poor power consumption, and stability, combined with IGZO's incremental speed and power consumption benefits in driving the smartphone display industry to innovate a new solution for increasing image quality while reducing power consumption: the variable image refresh rate pixel circuit. Integrating LTPS TFTs for speed and output current with an IGZO TFT for power consumption, the LTPO pixel circuit would be a breakthrough innovation for OLED and micro LED displays if it wasn't incredibly difficult and expensive to manufacture. So difficult and expensive that the leading smartphone manufacturers had delayed their introductions in flexible displays to the market for 2 years running, with the likelihood of 2021 being a third year of delay. Next slide, please. The future of high-performance displays, smartphones through gaming and TFT and TVs, will not be realized through continued evolution of semiconductor materials. Yet this is precisely the thrust of the display industry today: a search for a new, higher mobility oxide semiconductor. Amorphyx has approached the backplane technology Roadblock from a device engineering perspective. Instead of focusing on semiconductor materials, we rethink the physics and material science of thin film electronics to make higher performance, scalable, and highly manufacturable thin film devices that meet the current and future needs of displays: fast, flexible, and simple thin film electronics. Next slide, please. Amorphyx accomplished this revolution in thin film electronics by starting with first principles. How do thin film